Assalamu alaikum. Hello friends. I'm going to be sharing with you a Steam Tech battery management system project. So what is a battery management system? It's basically an electronic system that is responsible for correct and safe operation of the battery. Batteries are used in many electronic devices, from toys to smartphones to electric cars to electric bikes and scooters, forklifts, energy storage, and more. So we're just going to look at the one of the main important issue with these batteries. It's the charging and discharging. When it's not charged and discharged correctly, as I mentioned, it might cause damage, serious damage sometimes. So let's say just look at different state of batteries. We will be focusing on lithium-ion phosphate batteries, since it's very popular and most of the companies and markets is using these batteries. There are so many chemistry used in the battery system. There's a nickel metal hydride, nickel cadmium, lithium ion phosphate, and we're going to be using on we're going to be basically focusing on these type of battery, as they have the many good performance characteristic, from density, lifetime, charging, discharging percentage. So let's look at the a scenario where all the batteries are uniform and they're charged equally, discharged at the same time equally. But the problem, if you overcharge them or discharge them, it can cause problem to them. Some batteries, because of the nature of the chemical solution and electrolyte they have, they might not be charged equally. So when you charge them, you might have an even charging and uneven charging, and that actually can cause a problem because you continue charging the batteries and you might damage them. So let's say take a situation where we have a damaged battery like this one, for example. When the battery is completely empty, that's damaged. And let's say you didn't know that and you're charging this battery so you're charging it, you either overcharge it, you can damage it, or undercharge it and you might damage it. So in a situation like this, when you have this type of damaged battery among other good healthy batteries, you can actually cause damage to the other batteries. So let's say this is a damaged battery here and you're charging all the batteries at the same time, and without knowing, the two healthy batteries reach the top and you continue charging the other one. So what happened, you basically overcharge them and you can actually cause cell failure and damage the other two batteries. So you have everything damaged now. So what is a solution for this is really to understand the charging and discharging of battery and use a battery management system. And the basic battery management system rely on these limits. So for example, this limit here, the over discharge limits, and there is another limit which is over charge limits. These, if you go above or below, actually you can smoke and burn basically your batteries. And if you are in a high-speed car driving, and if you, of course, they all have battery management system, but I'm just saying, if there is no battery management system, it can cause serious problem. So these are the limit that we should pay attention. And when we develop in our basically battery management system, we'll be using these limits. And I just took, for example, the LiPo battery here, lithium-ion phosphate battery as an example. The threshold, you don't want to go below 2.5 volts. That's the over discharge limit, and you don't want to go above 3.65 volts. So basically this area here, this range from 2.4 to 3.65, this is your safe operating voltage. And another parameter that we will be also calculating is the state of charge, okay, percentage. So 20% is recommended, between 20% and 80% state of charge. You don't want to charge your batteries 100%. So 80%, these are like a safe operating ranges. From the 20% here, you see how deep, when you go below, it's not linear anymore. You go below 20% discharge. And you don't want to also go to stay safe. I mean, you can get closer to 100, but you know, we're just taking for precaution, we're taking that 80% is the safe zone. So let's talk about different battery package or packs that you can make. So we'll be talking about how actually battery are packed. So let's look at the series, case. So when you have batteries put in series, for example, so you flip each one, and then basically you just connect the top. So you have positive to negative, positive to negative. So you're connecting all your batteries into series, positive to negative, and continue like that. So you will have here the positive comes from here, and the negative, it will be here. So in this situation, as I said, let's take a case of lithium-ion battery. That's what we're going to be working. So the 3.6 volt, that's the nominal voltage, and the capacity is 3500 milliamp hour. In this situation, when you put all these 9 batteries in series, what you're going to end up with is instead of 3.7, so you will be 3.7 times 9. That will give you 33.6 volts. So you have a battery pack of 33.3 volts. And since we put everything in series here, so the capacity stayed the same. So it's 3500 milliamp hour. Okay, let's take a larger number. So instead of having 9, so I doubled. So there is now 18 of them. So you put 18 batteries in series, and what you're gonna come up with 66.6 volts with always constant capacity, 3500 milliamp hour. Now let's look at a situation where you want to actually have more punch, like more capacity. So let's say I have my 9 batteries, and I put them all, I didn't flip them, so they're all connected positive here, and the negatives are connected with the negative. So what I will do, let's say, what is my voltage here? Well, the voltage stay the same, 3.6 volts, 3.7 volts, but the capacity doubled or multiplied by 9. So we have now 31.5 amp hour, so much larger. So, but when you're making your battery pack, it's combination of series and parallel, and that's actually based on your design and how much power you want to have, what is the range that you want to have, what is the device load that you have. So there are so many things that maybe we'll be talking about this in a different video. So I'm just showing some examples. For example, for the battery battery pack of an electric bike, since the purpose of this project is really to build one battery management system that can be used in electric bikes and scooters. And since that's my kind of my project, looking for Africa, basically to make scooters, electric bikes, since we have abundant energy coming from the sun for recharging, and so that's one of and then also, I mean, the same battery management system can be applied to automotive industry, since you just basically have to create a modular pack and then make it larger. And I will be showing you the components and all the circuitry we'll be using for that, So this is just an example of battery pack. This is the battery management system, the electronic part that control all this overcharging, discharging, state of charge, and all that is done and calculated within this electronic system here. This is what actually keep all these cells in a healthy and correct operation. And these are the 18650 LiPo cells I was talking about. Here is another pack design showing basically the this is used in one of these electric bikes here in the USA. Here is another pack, but this time for a EV or electric vehicle. So the pack itself is right here, is the under the car, the chassis basically is all batteries and cells. So if we go and try to see what's under that battery pack, you can see basically the cells are under this sheet here. These are all, well, they don't Tesla doesn't use the 18650, but use a different size, 21700, and we'll talk about that. So this is the battery cells here, and as you can see, there are hundreds of cells. It's very, very large, very powerful. And the battery management system is this one, and then all the wiring to connect each cell for monitoring are going to this harness here. So there are different type of LiPo batteries. There are cylinder cells, and as I said, there are so many sizes based on the design and implementation. The 18650, 26650, 32650, 21700, and this is what's used by Tesla. So the first digits, basically, it's nothing but the radius. So this is 18 millimeter, the radius of the cell. And the next two digits give you the length of the cell itself. So that's how big and how big, as I said, for different design, different implementation needs, you choose a different type and size of batteries. Okay, and there are other type of lithium-ion battery, the same chemical, just different sizes and density. We won't be talking about these prismatic and pouch cells, which you can find them for in storage and different scenario where space is not a problem, or solar panel storage thing, project like that. Okay. Let's talk about the battery management system, because that's the goal of this project, is to create a BMS or battery management system. So what is the battery management functionality? So one of the main functionality of battery management system is monitoring. So we monitor each cell, we measure basically the currents, we measure the voltage and temperature, and based on these parameters here, we can do cell balancing. So the other functionality is battery control. So we can do cell balancing, state of charge calculation, state of health. That's another parameter that can be calculated that give you how long your battery life basically is going to give you, basically protect your cells by charging and discharging, controlling these elements here. And of course, if you calculated all this information, you should be able to basically display this for the operators either on his phone or some kind of LCD screen. So the battery I'm working on, and I'm gonna go through the circuit later on. So basically it will have like a master battery management system, and you will have slave basically BMS. These slaves, they're connected to cells. That's how you get the reading of currents and voltage. So we connect based on the chip we're using. There's so many cells you can connect to each slave, and then you put them in series. The more cells you have, more of these slaves that you have to add in series, just like that. And then you connect everything back to the master battery management system using what we call an ISO SPI. We're going to be using a chip, and I'll be talking about that. So for the microcontroller I choose for this battery management system is STM32, and it's going to be H family due to the high performance of this microcontroller. I also choose from analog devices this LTC6820 chip, basically that will convert the SPI format, this is transceiver, to an ISO SPI. This connection here, it's nothing but a twisted pair. So only two wires basically are connecting, either from the slave BMS back to the master BMS, or between these slaves we're using also twisted pair. And to connect all these 18 cells, basically we use this chip LTC6813, and this one has basically can control up to 18 cells. So more cells you need, you either put this chip within the slave in series, and then you can have more. I'm still have to decide how big I want to have that model. I'm still working on the design, or just have more slave boards just like this. Okay. So basically that's the project I'm working on right now. I just decided basically to spend more time on this master BMS, and I'm gonna go through the design, and then I will be working on the slave. So the slave are the same. So once you design this, it's basically just have copies of the same. So let's talk about how the circuits and how everything is connected.